Hey everyone. So in the previous video we were talking about homologous series. We know that homologous series means it's a group of organic compounds which have a general formula, which means a fixed pattern in their chemical formula, and their physical properties gradually change. So we know that alkanes and alkenes have their own individual homologous series. Every time it's a member of the alkane series, the name is ending with ane, ane. And when we are talking about alkene homologous series, the name keeps on ending at ene, ene. I'm again overpronouncing these because I want to make sure that when we're talking about methane, ethane, propane, we know that they belong to alkane series, and that means they are not going to have any carbon-carbon double bond. But when we are talking about the alkene series, they have one carbon-carbon double bond, and the name ends with ene, which means ethene, propene, butene, pentene. So this is what we should keep in mind. In today's video we're going to be talking about the word general formula, and we're going to see what the word general formula means and how we can use it. General formula are fixed pattern for each homologous series, so each homologous series has its own general formula. So when we are talking about alkanes, and when we are talking about alkenes, I'm gonna again underline these endings, alkanes and alkenes. So alkanes have a general formula where the number of carbon is n, the number of hydrogen will be 2n plus 2. So if the number of carbon is n, the hydrogen would be twice the number plus extra 2. So for example, just to help you solve it, for example, if I'm talking about one carbon alkane, so hydrogen would be twice the number of carbon, which means 1 multiplied by 2 plus extra 2. So 1 multiplied by 2 plus extra 2, which means 4. So it becomes C1, which we don't write 1, CH4. Similarly, if the number of carbon is 2, the hydrogen would be twice this number, which means 4, and then plus extra 2. So just twice this number of carbon plus extra 2, and it becomes C2H6. Whatever you do is you just simply twice the number of carbon and then you add extra 2. You double the number of carbon and then you plus 2. So here the number of carbon is 3. So you just double it, which becomes 6, and then you plus a 2, which becomes 8. So it becomes 3 2s are 6, and then you plus extra 2. So it becomes C3H8. For C4, you just double it, becomes 8, and then you plus 2. So double the number of carbon, and then you plus extra 2, so it makes the number of hydrogen. You get 4 times 2, then plus extra 2. So it becomes C4H10. Every time, no matter how many carbons there are, you just double the number of carbon and then you plus 2, so it becomes the number of hydrogen. And this is how you create formula for alkanes. One carbon alkane was known as methane. Meth means one carbon. 2 carbon alkane was known as ethane. Eth means 2 carbons. 3 carbon alkane means propane. Prop means 3 carbons. 4 carbon alkane means butane, and butane means 4 carbons. The general formula of alkene is much simpler. Alkenes have a very simple general formula, which means CnH. Whatever the number of carbon, you just double the number, you get hydrogen. So if it's a 2 carbon alkane, over here it's a 2 carbon alkane, just double it and you get the number of hydrogen, which is C2H4. If it's a 3 carbon alkane, just double 3 and you get 6. So it's H6, C3H6. For a 4 carbon alkene, just multiply by 2, double the 4, you get 8. So it's C4H8. Even the naming has a similar pattern, so it's ethene. Eth means 2 carbon, ene means alkene. Or you can say propene. Propene means 3 carbon, ene means alkene. Or you can have butene for that matter. But means 4 carbon, ene means alkene. So every time the general formula is followed, that alkanes have double the number of carbon plus 2 hydrogens, alkenes have no adding extra hydrogens, just simply doubling it. So alkanes will have always 2 more hydrogen than alkenes, number 1, and each have their own general formula, and even the naming pattern is very similar. For example, if I'm talking about C5 or C6, so let's say C5 alkane, C5 alkene, C6 alkane, C6 alkene. I know that for alkane, I know that I double the number and then I add extra 2. So 5 2s are 10, and then it should be plus 2, so it becomes 12. So 5 times 2 is 10 plus extra 2. So 5 carbon alkane would be C5H12 and 6 carbon would be C6H14. For alkenes, I just don't add anything extra, so it's C5H10, and for C6 it's C6H12. You just add, you just multiply it by 2. You just double it. You don't add anything extra. 5 carbon in organic chemistry is pent, so pentane and pantene. Pent means 5 carbon, ene means alkene. Or 6 carbon means hex, so you can be having hexane. Hex means 6 carbon, and hexene. Hex means 6 carbon, ene means alkene. So 6 carbon alkane or 6 carbon alkene would be hexane, hexene. Similar pattern of naming, similar pattern of making formula, just 2 different general formula. So alkanes have a general formula of this, alkenes have a general formula of this. And we're going to remember this. We're going to keep making structures, and we're going to try how to create these formula and make the names as well. So in the next video, I believe we'll be much more prepared with the basics of organic chemistry. So we'll jump on to some extra stuff of organics. Stay tuned, guys.